Runlevels. I promise to make this video shorter than the last one on Raid. In this video, I'm going to be covering Runlevels, and basically I'm just going to go over the SysVInit run level system, if you like, and the System D one. So I was going to touch on Upstart, but it's been discontinued by Ubuntu. It was developed by Ubuntu, and then they discontinued it in favor of System D. So I'm not really going to cover that. But yeah, System D is the main one that's used now. SysVInit is the one that used to be used. You can still do some of the commands that were available from it. So yeah, let's crack on. So here we are in our favorite VirtualBox VM, ready to go. I've already booted it up. It's the same one we've been using through the entire Linux tutorials that I've been doing so far. Nothing else has changed since the last one, which was the Raid video, and we're just going to get going. So I'm going to do a quick overview of SysV. I'm not going to go into depth on it, and I'm not really going to go massively into depth on System D. I just want to introduce you. They're both service managers. So quickly covering SysV. SysV is an older standard, and it provides a predefined set of system states known as run levels. Their corresponding server script files to be executed are part of that. So run levels are numbered 0 to 6 and are generally, not always, assigned to the following purposes. Run level 0 is shutdown. Run level 1 is single user mode, and that comes without network or other non-essential capabilities. So it's basically a maintenance mode, a super user kind of maintenance mode. I guess if you want to compare it to Windows, it's a bit like safe mode, essentially. You've then got run level 2, 3, and 4. Run level 2 and 4 are generally not used often. They can be, but they're not. They're multi-user modes, basically. It means that multiple users can log into the system. But they only allow users to log in via a console or the network. So, for example, right now, I'm logged in via SSH, so I could run the system in run level number 3 as multi-user mode. The thing is, though, by default, Ubuntu's installed this system with run level 5, which I can confirm by running the command run level. And you can see here it says N5. Run level 5 is the same as run level 3, but it has graphical mode available, which means that if I had a desktop installed, it would be displayed when I boot the system up. Run level 6 is system restart. So if I ran run level 6 now, it would reboot the system. I will quickly show you that in just a sec. First, I'm just going to cover this. So the N and the 5. The N shows the run level of the last boot, and the 5 shows the current run level. Okay, so if I switched my run level to run level 3, then that would say 5.3 because the last boot would have been number 5 and the current boot would be number 3. You can actually still run the run level command to see what run level you're in, and you can also still use the init commands, as I will show, well, now. If I just do init 3, that's going to disable graphical login now. Not that I have it, but it would disable it. It doesn't change the permanent run level though. So if I reboot now, it will just come back up with N5 because this boot is run level 5. I've dynamically changed it on the fly while the system is booted, and then when I reboot again, it will come back as run level 5. So the previous one will be the same as the current one, and that's why the N exists there. This says 5.3 because it says on this running system right now, the previous one was 5, and it's now at number 3. So that's what you see in there. I'm going to just quickly do run level 6. So really quickly, just to cover what I'm actually doing here. Init basically is a SysV thing, and you can do init something like 0 to 6, and that will switch to that run level. That's all the init command does. So if I do init 0 now, it would shut the system down. If I do init 6, it will reboot the system, which you can now see happening in the top right over here. So there used to be a file called init tab where you define all of your default run levels and much more. I'll link to the LPIC exam, not the LPIC exam, the LPIC learning resources below in the description, and that will give you a little bit more information on this if you want to read up a little bit further on this. I'm personally not going to go through all of this too far because, you know, there's a lot on this, and considering it's slowly dropping away, I don't feel the need to go into it too much. It does still exist. At the end of the day, SysV is here because I've just run the commands for it that interact with that system service manager. So I'm going to quickly log in again, and always sudo up at the moment because after the last video, we had a lot of problems there. So yeah, there used to be a file called init tab. I don't think it's included in Ubuntu anymore. No, you see, it's not even part of the system anymore. So I couldn't make any edits there if I wanted to. I suspect what will be happening is it's set as a kernel parameter instead of via the init tab, because my system runs on system D, and that will be the system that defines the run level that I'm booting up in. It's just that SysVInit has some interoperability, I think that's the right word, with systemd. So yeah, the services that are managed via SysV, sorry, is stored under init.d. So you can see here there are services defined, and you've got AppArmor here, cron, grub common, LVM2. There's, well, you can read these, there's a lot under there. So I'm just gonna cat out the, let's go for AppArmor. Let's just go for that one. And you can see that all this is a script, a shell script. Let me just go up a little bit further. You can see here it's a shell script, and it has some description at the top, a few functions defined, and then a little bit further down you have this case here that basically says the command that's provided, which I'll show you in just a second, can take start, restart, reload, force reload, stop, data, status, whatever. So how do you interact with these scripts? So you can do service, and then you do AppArmor, and then one of those case options. So for example, we can do stop, that will stop it. We can do status, and that will show that it's inactive. And then we can do start, and that will show that it's running and it's active. Yeah, so that's how you'd interact with the SysV based system in terms of the services that run on it. Now, again, you'll see on some systems there's very rarely anything in initd anymore because things are moving away, and that interoperability with systemd allows systemd to interact with the scripts here as well. So I will show you that in just a second as well. So yeah, that is essentially SysVInit in a nutshell. Let's quickly go over systemd now. Currently, systemd is the most widely used service for managing services, for want of a better wording of that. And it actually refers to resources, well, system resources and services as units. There are 7 types of units and corresponding configuration files. The 7 types are service, socket and device, mount and auto mount, target, and snapshot. I'm not going to cover them all right here, but I might pop a link down into the, well, I will pop a link down into the description to the LPIC exam training resources. They do go into those a little bit more, and they go into Upstart a bit if you're interested in that. So as I said, systemd has units that have a name, a type, and a corresponding configuration file, and it has 7 distinct types of systemd units. I've already just spoken about them. We'll cover a few bits relating to systemd. So anything to do with systemd is generally done with systemctl. You then have the command that you want to run, and then the name of the unit. So I want to work with AppArmor here. So you can see here, I've been doing things via SysVInit. I can also do things via systemd using the systemctl command. So the options here are start, stop, restart, status, is active, which will tell us if it is active right now, enable, which will enable it on boot, and then disable, which will disable it on boot, and then is enabled, which tells us if it's enabled on boot. So let's check AppArmor out. Now, AppArmor isn't defined under the systemd setup at the moment, I don't think. We'll have a look at that in a second. Just come back. Let's just quickly confirm that. So you'll see systemd scripts essentially that are stored under etc, systemd, there'll be some there, and then you'll see some more under system, so, and network and other places as well. So I don't have an awful lot of stuff installed on here, but you can see here, just quickly scroll up, you've got here this OpenVM tools, and then down here I also have OpenVM tools. So this has both set up essentially, but this has a requires here. So if we just take a look at that real quick, I'm just going to have a look at that. And that's basically saying that the OpenVM tools requires this service. So let's cat that out and have a look. So in here, this isn't a script, it's just a definition. So the unit has these parameters essentially. So description, bit of documentation about where you can find more information about this service. And then that it should run after these, that it's part of these, and then it has some service information. So it gives you the path, the timeout to stop, and what it's required by. So it's a bit easier to write a systemd unit file than it is a script for SysV, I would say personally. So yes, there you go. That's another one. Let's have a look at SSH. There's SSH in there. And we'll just have a look at ssh.service. You can see here again, this is the SSH service unit section. It's still got the same things, the service, which gives us the path to the environment file, the SSH command with the options that it requires, yeah, there's a lot that you can do in here. You can get a lot of information online about how to write a systemd unit file. And as I say, I personally feel like they're easier to write and easier to understand than the scripts that you've just seen for AppArmor, for example. This is, let's face it, a bit of a mess of stuff and definition and functions. And, you know, it's a lot harder to manage something like this, I think, than it is something like this. Anyway, I digress. So, as I say, you've got systemctl, status, app, armor. Let's have a look. There we go. And you can see we pretty much get the same as we do from here. And if I spell it right, we will get that. So yeah, here we've got pretty much the same. In fact, looking at it, it says exactly the same. You get the same output from it because there is that cross compatibility between the two systems. So yeah, that's how you would interact with the service. So I could, on the systemctl command, I could disable this on boot, I could enable this on boot, or I can just see if it is enabled by running this command. And it is. There you go. We can also see if it's running using this. There you go. It's active. It says it's active. And that active status is from here. You'll see sometimes that you'll have something like .service on the end. So basically, if no other units with the same name exist in the system, then that suffix can be dropped. And it will still work. For example, if there's only one web service like HTTPD or Apache or whatever it might be, you can just get rid of that .service. There are some things that they may clash, and therefore you will need to have that .service on the end. So other things we can do with systemd, systemctl. Let's have a look. We can do, we can isolate a target, and the isolate alternates between different targets. So you can alternate to the multi-user target by doing multi-user.target. And that's the same as run level 3 and run level 5 that we were talking about earlier. And if I do that, it will tell me that I can't spell, which is correct. And it's still telling me that I cannot spell. Let's just start again. So that will switch my run level, and yeah, there you go. You can see there it's switched. And again, I'm using that run level command, which is originally from SysVInit, and there it is right there. So if I do init 5, for example, switch back, and then I can do this, and there you go. It's switching back and forth. So it's essentially, again, it's that cross compatibility. We can also do things like systemctl run level 3.target. That is not correct because you need isolate. So that's my problem. And we'll do 5 again, and run the run level command, and then we'll do 3 again, and the run level command, and you can see again switching back and forth. So yeah, and you might be wondering how that would work. I'll show you that in just a second. There is another option here that we can do to change this permanently on boot, because obviously we don't want to have to boot it and then switch our run levels all the time. So we can do etc default and grub. And I've mentioned this in a previous video when we talked about grub. And to do that, we can set a kernel parameter in either one of these, and one of them is on every boot, one of them is on normal boot. And we can just set one in here, and it would be something like systemd.unit equals run level, let's spell it correctly, run level 0.target. Don't do run level 0 because that's shut down, run level 5.target. And that will always make it boot into run level 5, for example. Or as we just saw, we can do multi-user.target. I'm not spelling very well tonight. So this is a way we can manage that. I'm not going to save that, but that's a way you can switch run levels on boot. So that's the isolate command. You can see what the default is by doing systemctl get default, and that will tell you what the default is. So in my case, it's the graphical target, as we already know, because we saw that in the original boot when we did it in SysVInit, and we just ran run level when we first started up. You can set the default by doing, for example, we did the isolate command before. We could run the set default command, and that would set the default to be run level 3.target or multi-user.target if that's what you want to run instead. So yeah, that's how you change your run levels on boot with systemd. You've also got things like systemd list unit files, and that will list all of the unit files and whether they're disabled, enabled, and more information. There's a lot under here. I won't go through all the lines, but you can see, for example, let's just have a look. We've got, where's my mouse gone? There it goes, run level 5, which is static, run level 6 is disabled, run level 0 is disabled because if they were enabled, it constantly shut down or reboot when you start your system up. Yeah, so if we go and find the graphical one, I believe it'll be around here. There you go, there's the graphical one, that's static and that's enabled. It's, yeah, so you can list all the unit files that way, but they are actually stored under lib systemd system, I believe. Let's just double check. Yep, so you can have a look under system, and under here we have lots of targets that we can use, and here are those targets. Let's just have a look at the level 5 target, for example. And we can do that and that. Oh look, run level 5 links through to the graphical target. Who was shocked by that revelation? Not me. You can see how this all symlinks together, and there's stuff going back and forth all over the place, and that's where that connectivity, if you like, between the SysVInit and the SysV service managers work. And yeah, that's pretty much everything I want to cover on those two right now, because I feel like that was quite a lot there, and you need to play with it a bit to get used to it before maybe going any further with it. So yeah, there's the two service managers that I wanted to talk about. So you had something as well called Upstart, which was developed by Ubuntu, and you didn't use the init tab, but the legacy commands of Runlevel, and I think it's Tellinit. I don't think Tellinit's used anymore. You can still use it, yeah, okay. So that's still in there. I wasn't sure if it was still there, to be honest, it's been a while. So you can use Tellinit to send Runlevel commands through. Again, it's a legacy thing from the SysV world. Yeah, Upstart was developed by Ubuntu, but in 2015 they got rid of it and switched systemd because systemd was very mature. It was pretty much being used across the board everywhere else. So Ubuntu just threw Upstart out and carried on with systemd. I'm not going to go into that now. Again, that link I'll put below to the LPIC tutorial bits that I was talking about. We'll have information on that if you want to learn about it. It's got a really short piece on it just to tell you about it, but you don't need to know about it because it's gone. There's no need for it anymore. Final bits. Let's just talk about shutdown, reboots, hibernates, things like that. So you can shut down the system using shutdown, halt now, or restart now, or you can run power off, or you can run reboots. There are a number of options there available, but to be honest, reboot and power off are pretty self-explanatory. Shutdown, however, can be used in multiple different ways. So I could restart the system at midnight by running that command, or at 2 in the morning, or at 2:30 in the morning. Let's do that. There we go. Shutdown scheduled for this date and this time. Use shutdown C to cancel. Well, let's go ahead and do that. So we can do that. That's fine. So you can also do Control-Alt-Delete on systems. I'm on SSH right now, so I cannot do that. You can change the time as well there, by the way. I could say 5 minutes by doing +5, and that will change it to 5 minutes from now. Let's just cancel that. You can do restart now with 0. I appear to have numlock on. Yeah. Numlock off, sorry. So do that. I could do that, and that would restart it right now, or I can just write the word now. So there's a few different ways you can provide times into the shutdown command to schedule shutdowns in the future. Yeah, so they're the shutdown commands. Just a quick note, for example, we've got the power off command I was talking about. We can run which will tell us the location of that. So we can do that, and that will say this is where the power off command lives. We can then do an lsal on that, and that will show us where that's linked to, because telling you it's a symlink. There we go, power off. Oh, look, it links to systemctl. How about that? There's a few different ways that we can do shutdowns, power offs, reboots, and more. You can also do systemctl hibernate, if I remember rightly. I'm just going to double check that. Do I want to do this? I'm going to do it. I don't know if that's the... Oh, yeah, there we go. There we go. It goes into hibernate mode. So that will just carry on where it left off. So I'll just boot that back up. It will store the current state essentially onto the disk, and then when you boot back up, it will carry on where it left off essentially. So yeah, that's your hibernation. It's the same as like Hibernate in Windows and other systems as well. Yeah, like I say, it copies all the memory data to disk, and when you power it back on, it will carry on where it left off. So yeah, there you go. There's the SysV System Manager, the systemctl systemd system manager, and a little bit of information about shutting down, rebooting, and managing shutdowns of a system. So I'm going to reconnect to this, and yeah, call it at that. That's everything. That's all I'm going to cover on Runlevels. As promised, I wanted to keep it short, so I've done my best. In the next video, I'm pretty much going to start winging it, because I'm not really sure where I want to go from here. I really want to crack on with the Kubernetes tutorials, but I feel like there's a few other things I could probably cover in Linux first before moving on to Kubernetes. So I'll cover things like installing Docker or Containerd, sysctl, how namespaces and user spaces work in Linux, just kind of give you a bit of groundwork and prep work for moving on to the Kubernetes stuff. So there'll probably be another maybe 3 or 4, I'm not sure yet, videos on Linux. And once they're done, time to move on to Kubernetes. So see you in the next one.